what are you really asking for as far as health and safety, as ventilation and filtration inside these homes? No, your house does not need to breathe, right? Like that's the passive house has been proving that over and over and over again. Like point 0.6 air changes. Like we don't breathe through our skin, we breathe through our lungs. Let's put a lung system in our building, right? Like all these things, concepts that a homeowner could wrap their head around so that they felt like this was a good resource.
Hey, welcome to episode 16 of the Reimagine Edit, which is our special series of the Passive House podcast that focuses on the conversations that are happening inside the Reimagine Buildings Collective, which is our membership community. I'm Zack Semke. I'm host of the Reimagine Buildings Collective, as well as director of Passive House Accelerator, and I'm excited that you're here. That clip that you just heard was a great example of the kinds of conversations that are happening inside the collective. That was from Emily Mottram, and she totally nails it with that plain language on mechanical ventilation and that reminder, hey, we don't breathe through our skin, we breathe through our lungs. Maybe we should be focusing on creating lungs for our buildings rather than this trope about buildings need to breathe. So this episode, we're going to focus on the business side of building better. So how do you build a practice around this work? How do you pay for it, price it, sell it? How do you get builders and architects pulling in the same direction? We'll hear from Emily Mottram, who I just mentioned, of Mottram and Mains, Jesse Hunt of Emergent Development from Houston, Ben Bogie of Building Performance Cooperative, and Ed May of Building Type. And all these conversations came from the questions and answer sessions and AMAs and interviews happening inside the collective. So specifically, Reimagine Design events, Reimagine Construction events, and AMA Fridays. Emily recently joined forces with Michael Mains, who's her co-author on the book, The Pretty Good House, which many listeners are familiar with. And so they created the architectural firm together, Mottram and Mains. Here in this next clip, she's in her Reimagine Design conversation with host Michael Ingui. And she's talking about starting a firm at the worst possible time.
Maybe tell us a little bit about your firm prior to the new firm name, and maybe talk a little bit about that. We'll just kind of start at the end here.
I think that's actually a really good segue into what you guys are trying to do like this season and as part of it. In 2009, it was considered gainfully unemployed to be an architect, if anybody remembers being an architect back in the 2009 era. So I decided I was going to start my own business, right? I was going to start my own practice in 2009 when there was just not a lot going on. And I was recently licensed. I had worked for a couple of firms before that in Washington, D.C. And then my husband and I flipped a coin and we moved to Maine because that was where he was from. So another great story. But I decided I was going to go out on my own. And I went to the Small Business Administration. I said, how do I do this? And he said, you're really young and no one will ever hire you. So like, aside from the fact that like there just wasn't a lot of work going around in the residential market in 2009. And then, Small Business Administration was like, I don't know what you're going to do. I held on to that for a really long time, but I looked at the state of Maine and I said, what does Maine need? And what they really needed were people who were doing energy auditing, energy consulting. And as an architect, that was the best thing that I could have done to learn about building, as I was getting into existing buildings, learning what other people did, learning how to make them healthy and safe, which I think is still something that a lot of people don't know they need to do, which is a little scary. But like from the very beginning, we're like, okay, here's the health and safety things that we need to do before we do anything else. And it taught me how hard it is to make a building energy efficient after it already exists. So I thought there has to be a better way to be a better architect, to think about these things as we're doing schematic design. And so that was what I built my practice on. I did a lot of energy consulting for a number of years until there was enough money in the state for people to start actually building and designing and retrofitting houses again. I grew my practice. So from 2009 to 2013, it was just me. Then I added somebody who helped me do a little bit of drafting work. I partnered with another architect who would just like help me here and there. He still works with me today, although he keeps telling me every year he's going to retire. And I'm like, not this year, not this year. So over the last couple of years, I've grown my practice to there were 7 of us. So we have a full interiors team, we have project manager, we have a front office, admin, financial person. We have 2 architects. And as of the first of the year, as you heard, I think that's the first time I've heard anyone say it out loud, Michael. So you get to be the
Mhm.
first. Um, we have merged with Mike Maines, who was another author from the Pretty Good House book. And so we have merged our 2 practices together. So now we have 2 principals for our architecture practice. And he brings a lot of the same mindset that I've spent the last however many years. He's done the same thing, which is the stuff that we really care about: the health, the safety, the building science, the building beautiful residential structures that are also healthy and great for the people who live in them afterwards.
That's very cool. Maybe talk a little bit more about what a pretty good house is.
Yeah. So, um, at the time, we were really trying to just see what made sense in our market. One, what can you get, right? That's always the
Mhm.
hardest thing. Like, what is actually available to you in the market? Two, what's good building science practices, right? Like,
Mhm.
what is thermal bridging? How do we get around that? How do we build with certain materials? How do we do, extension jams? How do we make sure we have condensation resistance? So just starting to really get people to dig into the details. It also is asking people to start thinking about where you want to spend your dollars. And that's one thing that Pretty Good House wanted to bring in, which is we want you to make improvements until it no longer makes sense financially for you to do so. And
Yep.
to use the design to help you do that, right? So to build
Mhm.
simpler things that are easier to insulate so you can get higher insulation value. There's nothing quite like sitting next to that triple pane window during a snowstorm and it not being cold, right? So getting people to
Mhm.
understand that, getting people to understand the health and safety impacts both of building, because we want people to know that you're doing building science, whether you admit you are or not, just because
Mhm.
of the materials that are available in the market. So we wanted to make it a little bit easier because when you say building science, that makes people a little bit afraid.
Yes.
Um, but also to bring the conversation in for at a homeowner level so they knew what to ask for, right?
Mhm.
What are you really asking for as far as health and safety, as ventilation and filtration inside these homes? No, your house does not need to breathe, right? Like that's the passive house has been proving that over and over and over again. Like point
Mhm.
0.6 air changes. Like we don't breathe through our skin, we breathe through our lungs. Let's put a lung system in our building, right? Like all these things, concepts that a homeowner could wrap their head around so that they
Yeah.
felt like this was a good resource. So Pretty Good House just kind of goes through a series of things that you should think about. It's not in sequential order on the way that you would build, but it brings in material choices. Have you thought about the carbon impact of the materials from day one when they arrive on your job site? Have you thought about how healthy that material is for you inside of your building? Have you thought about the building science that will make your building itself healthy with condensation resistance? And so, Pretty Good House was about why we should be doing these things and trying to get homeowners and people who are new to the industry or maybe just new to the idea of building science to understand how these things connect together. And so we
Cool.
wrote a
Yeah.
book.
Yeah, so Emily and Michael Maines wrote a whole book about this based on the idea that homeowners deserve to understand their buildings. Of course, philosophy only gets you so far, right? It still comes down to the people who are building the building and them all being on the same page. And Reimagine Buildings Collective member Brent Watanabe picks up on that in this next clip. By the way, he mentions BS and Beer, and that's the building science event series and community that Emily and her partner helped build, and which has been a great model for getting builders and contractors in the same room, away from active project pressure, to dive into building science and best practice. But here's the next clip.
You've worked with some of your contractors for, you know, the last 10, 15 years. Like how did you, is that because you had BS and beer, or like how do you get that contractor base where we don't have any of that, I don't know, uh, camaraderie, I guess, yet.
Yeah. Well, I feel like the idea that people don't want to collaborate is an idea we hang on to, which may not be that true. So like I have people who just reach out to me and they're like, "Hey, just trying to connect with other architects." And we can do the same on the back end is like I'm just trying to connect with a couple of builders. And I've
Mm.
met some over the years where I've left the office and been like, that wasn't it." Like, okay,
Yes.
you were nice, but like you want to spray foam absolutely everything, and you don't care about the environment, and you think that's the fix all to everything, and like you're not going to listen to anything I
Yeah.
have to say, right? So you can kind of get that vibe earlier on, but a lot of times, they're busy. They haven't made that connection yet. And yeah, Maine is a smaller community, so it works really well for us because, we have a good base here. And we have the discussion group. So like Steve has fostered this relationship for a lot of us, which is really great. But essentially it's like creating a network or just meeting other people because a lot of them want to do this, but as you know, when you're half of them don't have a front office staff or anybody who answers the phone or whatever. And so when they're working and they have the tool belt on all day, they don't have time to go and look for, an architect or a partner. And so
Yeah.
sometimes you want to get to the point where you can do that, and it might mean that you do a project with them. And then you show up to the job site and you talk to them on the job site and you
Mm.
learn from them or whatever, and you establish a little bit of a relationship with them. You know, how are you doing this? Was the my favorite thing to do is go to my job sites and take a picture of my drawings on the job site and what they wrote on it. That's a great way to learn what they didn't know or what they had to figure out, like as part of it. And so then you have that conversation. You're like, "Oh, your job site drawings. You wrote this on here. How could I have better presented that? Or was
Yeah.
this a bad detail?" And so sometimes it doesn't start early until you have a relationship with that builder. But once you do, and you can say, here's two or three meetings that it would be great if you showed up to, and you can help us while we're early in the design phase, going like, oh, that's going to be really expensive, or this is how we would build it. Because then, as the architect, if you draw it how they're actually going to build it, they'll look at your drawings, which is great. So, um, so to start that relationship, sometimes you just have to do a project and you have to go to the project and you have to figure out um who's in charge. Because I always thought the design build firms would just have this naturally baked in. But it's been really fun to visit some of my friends now who have design build firms and learn that like the field team is like, oh yeah, if our architects would just do this. And I'm like, man, you guys, you're the same office.
Same company.
So
Yes.
like
Yeah.
Yes.
So I think it's good for everybody, no matter what type of firm or company you work for, is to like spend some time on the job site, get to know your PMs or the people who are physically doing things, and then you eventually get to the point where you know what questions to ask, you know which meetings it's really important. And so we do a couple of different estimates during design, and the first one we do is the good faith estimate, which is like we've gone through schematic design where we have a direction. It's not a lot of detail. You could probably put some square footage pricing to it. We all know square footage pricing is not even remotely accurate, but at least it's
Mhm.
kind of using some of their numbers. And you do your good faith estimate, which we call it that so people don't think that it's a budget. It's not a budget. We're not holding anybody to it. We're just making sure we're still going in the right direction. Because if your good faith estimate comes back at 5 mil and you're supposed to be at one, you have a big
Yeah.
problem. Like,
Mhm.
hopefully you're not that far off, but like, that's the good check and balance. And then we do another one at the end of design development, which goes into pricing, which is when we have a lot more information. This is maybe when they might get their subcontractor. So, like, we don't want them to feel like we need them to do estimates a on a drawing set that has no information in it, right?
Yeah.
Because I
Mhm.
mean,
Yeah.
like, that's not the point of that set. That's getting the client to agree to a direction and a scope. Um, and so that's usually good for them, and then they get paid for that time. And so I think we write that directly into our contract that they A have to pick a builder and B they have to pay them a pre-con agreement so that
Mhm.
there's no
Oh,
There's no surprise to them that like their involvement during that part is going to cost something, but also we don't want them to work 80 hours and not get paid and the project not to go forward because we're so far down the road at that point that we can't pull back on the scope. And then
yeah.
instead of value engineering, um my friend Steve Demetric did a presentation with me. He's a builder in Rhode Island. Um, he said change value to values, and that changes the proposition for people, right? And so then you're
Yeah.
not value engineering out the stuff that makes their buildings health and safety. And so we just changed it to design refinement. So if we get to that point, we have a lot of things selected, and we're still a little bit over where we want to do, we're just going to refine the design. Like use words, language is important to people.
Mhm.
And so we do around a design refinement, and it's like if we're off by $500,000, you need to reduce scope. If we're off by,
Mhm.
a couple thousand, we can probably pull that out of our finishes. If we've got crazy built-ins everywhere, maybe we can pull back on built-ins because you can always do them later. And we try to help guide them through um, what they could pull back on, what isn't going to be crazy if they want to add later. But also, we tell them that it's not cost savings, it's cost deferment, and it will always cost more later. So, like that,
Yeah. Right.
framing that conversation and talking about money from the beginning and with the builder is always a really great way to get clients to make good choices during design.
Let's stay on this thread of running a practice. In the collective, people are increasingly asking not just how to build better, but also how to make a living at it. And Jesse Hunt has been trailblazing one really powerful approach to doing that. He's doing spec passive house development in Houston. And we're about to hear his conversation with host Michael Ingui in a Reimagine special session in the collective. And they really get into the financial side of things. So pro formas, cash flow, pitching investors, the kind of stuff that doesn't show up in building science textbooks, but can really make or break the next project.
Brent just asked a question. I'll ask it along with this, if you don't mind, Brent, which is the other one is just financial literacy, along with being in the financial driver's seat. So I'd actually like to stick on that. Brent was asking in his question if you had any recommended courses, but I'd love to also just hear a little bit more about just the financial literacy and being in the driver's seat. When you say being in the financial driver's seat, like how comfortable do you have to be in that seat is really my question.
You got to make it pretty comfortable because you're gonna borrow other people's money and you're gonna be burning interest once you do that, right? So
Yep.
you really need to have a good business plan put together on how
Hmm.
to use that money and use it effectively from a time perspective. The coursework that I took is called ACRE. It's like A.CRE. It's real estate financial modeling course. Very, very, very good. You'll learn a lot, and you'll learn more than you even need to know, especially on the first more simple project.
Hmm.
But your ability, I should say, to project like cash flow over the course of a year or two on a project is going to be
Hmm.
very, very beneficial to you by doing that work. Uh, so yeah, you definitely need to get comfortable. And I would say for me, the best way to go about, and it's actually kind of the same with like custom home building or any real estate project, is like the more planning you do up front
Hmm.
on paper, the less mistakes you're going to make in the field and the faster you can go. So for
Yeah.
me, we're especially on spec developments. Speed is like really, really important. And when construction gets slowed down, it's just going to eat and eat and eat away at your bottom line. And like
Hmm.
that first that first project really needs to be successful financially. So
Yeah. That
how
makes
do
a
you
lot of
close the
sense.
deal fast enough if you do all the front end work? So like there's ways around it, but you can the way I did it was I basically like pre-designed a project that would fit on a typical lot size.
Hmm.
And that's how I built a pro forma together. That's how I put together a presentation for investors. And the project had to adjust because we got a different lot size or something, that would be fine. But you
Mhm.
really sit down and do the work of like putting the whole deal together to be able to put a pitch deck together with your friends and family, and you say, look, I'm doing this crazy thing, which is passive house, and here's why I think it's going to work. And here's more importantly how I'm going to return your money and you know what the risk factor is there. So
Yeah, I feel like you're answering Brent's two questions right now, which is nice. But I think we stay again kind of stay here for a little bit while longer. Brent,
mhm.
maybe just combine the last two questions real quick if you don't mind. And I think this is a great point.
Yeah, and I mean I answered as first of the two, but
Yeah,
yeah,
I mean,
so like I
it,
said, you just have to put something together that's relatively robust to present to people. And then when you have the capital ready, that's when you go look for land, you tie it up, and you get cracking on real design as quickly as you can.
because it sounds like Brent's not wrong. I see it here, especially in Brooklyn and Manhattan on really fantastic properties. They're
Yeah,
gone fast,
of
really fast.
course.
So
Yeah.
if you don't have it all set, you're doomed.
Well, and here's the deal too. You know, the nicest lot in the nicest area might not be the best idea for your first small project.
That's that's a really good piece of advice.
So like
Yeah.
you know, I built this first passive house project in Houston. I'm sitting in it
Hmm.
right now. It was on an empty street,
Hmm.
empty lot with like rundown houses around it, and that's all since
Hmm.
finished, right? Once I started
Hmm.
this development, somebody else bought the lot next door, and they felt comfortable developing there, and the other
Hmm.
thing getting I've got the other lot next to me sold now, and like it's all changing, and I don't think it's a you know gentrification is a very complicated subject, but I don't really I see this as community development, not gentrification when the street was empty in the first place, right? So
Hmm.
I would say you're gonna need to sort of edge towards, you know, neighborhoods and areas where you can make the cost of land make sense with the cost of construction and your sales comps. So you're gonna be there's gonna be a feedback loop for you. I highly suggest you get like three or four like good friends that are going to be, you know, a real estate agent that will give you feedback. And it's got to be, these all have to be reciprocal relationships, right? Because you just asking somebody and asking somebody and asking somebody for info and you're not doing deals, you're not doing business together. You have to find a way to provide value, but you're going to need a real estate agent. You're going to need at least a friend who's a builder and can give you like high level feedback on cost. You're going to need, um, at least those two people, really. And I would say, you know, somebody who knows banking terms or make friends with a banker, start to get involved, like actively saying, like, okay, what's the interest rate? How bankable am I? How much equity do I have to have in a project to afford a project of this size? You're going to need to answer all those questions depending on your
Hmm.
market and how big of a project you're looking at.
Jesse's been pretty candid about what it takes to pull off spec passive house development in a market where nobody's done it before. Reimagine Buildings member Ranger Pinney in this next clip pushes on something a lot of us wonder about. And that's, can you actually charge more for performance when your finishes aren't, say, top of market?
Have you found that you can uh, translate the performance and quality into the cost, the price that you can charge, even with sort of what's perceived as lower grade interior finishes?
Yeah, so you know, if you look at the photos of the house, you would not question the level of finish in terms of you know, somebody buying a spec house, like looks really good. You just a little bit of design goes a long way, you know, like these
Hmm.
accent walls and make sure your countertops are really good looking, make sure your cabinets, you know, I've found really affordable cabinetry that is formaldehyde free, has dovetails, has soft closers, has all the things that somebody would be looking at initially, but you know, was not custom made whatsoever. Everything's standard sizes, right? So
Hmm.
get a little bit modular with your sizing and you get really careful about like maximizing the amount of square footage that you're building in the first place. Those are the biggest levers. right? So like how much can you fit? What's gonna move in this market, and get feedback from an agent. Your agent is gonna tell you they see so many deals. You say, hey, here's my plans. What's gonna help me sell this thing? And the other thing we did was we got a green appraisal. So you would look into if you have green appraisers in your area, and they can force banks to do a green appraisal.
Yeah, let's talk about that. How did you find that? Do you feel like it's in your market only? That's
No,
fun.
I'm in Houston, man. I've been inventing the wheel the whole time. So,
I thought I
um,
knew the answer, but I wanted to ask you
yeah,
anyway.
no, hell no. So there were no green appraisers in Houston, Texas. I had one trained just for my project by a,
Wow.
by a
Yeah.
third party.
Wow. Cool.
And if you all want me to connect you with somebody that can help you, but your New Yorks, your San Franciscos, your Oregons, you guys are more likely to have some of these folks. Uh,
Hmm.
but so I got an initial appraisal done when the bank was gonna get ready to close on my financing. So they do an appraisal to make sure your project is worth as much as you say it is.
Hmm.
They can lend on it, right? Uh,
Hmm.
and so we had that guy trained, and he was like, Jesse, there's literally no comps for what you're building. I was like, yeah, so how much?
Yeah. Uh-huh. Exactly. Yeah. Yeah.
And he was like, I think it's worth 10% more than anything on the market.
There you go. Yeah. That's a huge. We always we got a few gold nuggets for me. That's another one right there. That's
Yeah.
cool. Hmm.
So really high level,
Hmm.
it appraised for 10% more than anything else in the area.
Hmm.
And we delivered the project when we got to like our 9% interest rates. And so we put that thing on the market for 10% over and it sat. And
Hmm.
nobody was selling homes at that time.
Yeah. Hmm.
Took me a solid 6 or 7 months to close.
Hmm.
But we closed at 5% over in that market, in that horrible
Wow.
market. Yeah.
That's huge. And
Yeah.
I actually feel like that in those markets, it might be even more important to stand out from everybody else around you. You know,
Mhm.
someone saying to themselves, "Listen, I gotta buy a house out because I want to be here anyway," um, and then they're just looking for the best house they can. And I think it probably really helps you to be in a down market sometimes with a better product.
Yeah. So we had the green appraisal in our pocket. And no, not Brent, not the banker, the appraiser.
Hmm.
We also did a lot. I mean, we're coming from zero in this market. Nobody knows how, like, the level of quality is so different than anything else you can even go out and buy. You'd have to be
Hmm.
spending an inordinate amount of money to get a builder to do this in a custom house, right? The fact that I'm delivering it on spec, like there's so much value there. You just have to
Hmm.
find a way to educate the buyers and educate your real
Yeah.
estate agent. So my
Hmm.
friend and real estate agent, like he watched me do my spiel with people coming in the house to look at it so many times. And he was learning all my
Hmm.
language, and he was like, this is what this machine does. This is what that machine does. This is what air tightness is doing for you. And he really, really got good at that. And
Hmm.
because we certified it, we had a lot of data on the home. We had all this third-party testing data. We had tons of photos of construction. So you go to visit a typical spec home, they're gonna have like, wine and cheese and business cards. And we covered
Hmm.
our countertops and like the proof in the pudding of like everything that went into the house. So like all the envelope photos, all the testing data, we had
Hmm.
like nice big like billboards of like educational billboards of like what is MERV 13 doing for your air? How
Hmm.
tight is this house in relative terms to like the rest of the market? And like a
Hmm.
lot of that was just like spelled out. So even if I'm not
Smart.
there and like a random agent brings somebody in, they're still going to stumble upon all this and go, oh, wow, okay, that's a lot. And
That's
eventually
super
that
smart.
happened. It happened with the right buyer, and they were just like,
Hmm.
they saw it all, they went home, they started looking up passive house stuff, and they just couldn't believe it. And they were like, this is now, this is their forever home. They were like, we could not be happier where we live.
Covering the countertops with construction photos and documents and testing data instead of wine and cheese. That there is a passive house open house. So let's go back to Emily Mottram. Here, Michael asks Emily to reflect on what's changed over the years of her work of doing all this and what hasn't.
You had mentioned something earlier that I'd like to come back to, which is you were saying, if you remember 10 or 12 years ago, things were super difficult to get through. It's nice to have you on because you also have been doing them for a while, and I think you're also quite addicted to kind of doing them better every time. It's helpful because it lets me ask the question, what do you think some of the key differences are? Because a lot of people are coming into this brand new today. They haven't known how difficult it may have been to do it, but also I'm sure that you're still feeling like things are difficult in some other areas. So, what is some of the key differences?
Yeah, things are still a little bit difficult. We have not yet gotten past the part in construction where I've been doing it this way for 25 years, and so I will continue to do it this way, has gone away. We also are in a point in our industry where they will just continue to dump materials on the market. And I think I used to say there are no bad materials, but I think that might be wrong. There probably are some bad materials, but generally it's bad installs, right? Like if you don't know what you're asking your material to do, it can become an issue that it wouldn't previously have been because they're not apples to apples. Like we used to build buildings with skip boards and no insulation, and we just cooked them. So they weren't moldy. They didn't have
Yeah.
that stuff in them.
Mhm.
But now it's like, oh, nobody can afford to do that because the cost of energy is so high. So we're just going to dump a bunch of insulation in it. But if you
Mhm.
add more insulation and you don't do any of the other control layers, you should have just not added more insulation because it created an issue you didn't have before. And so I would say we're still in a really hard place where people don't understand the dynamics of building biology. They don't know when they change something, how that's going to affect the things. And they're just like, oh, well, this plywood is the same as OSB. Well, no, they're really two different things.
Mhm.
And maybe you want to use it structurally for your building, but if you don't understand what it's going to do and how it works in the system, they're really different. So I would say it's still hard because every time a new product comes on board, it might be the best product in the world if it's used correctly. But so
Yeah.
often, and like when you mentioned this about me, and that'll probably be always how I am, is like I love to be on the bleeding edge of whatever, like what's the next technology? What's the next thing? How are we going to do better? How can we provide more resilient buildings, more long term? And so sometimes that means you try things that you would never do again,
Mhm.
which is also a little bit challenging.
I've been there. Yes, I
Yeah,
have. Yes.
we've been there. When
Yes.
you learn things
Mhm.
and go to your job site, even if you get value engineered out, because you're going to learn things from
Mhm.
your builders and so now conversations that I'm having are like, how can our drawings be better? How can
Oh.
we connect to like the person who's going to use this sheet? What information do they need and how do they need to take it in? And what's the sequence? Like if we're going to be successful, how do we sequence this piece of it? And so now we're talking about drawings and I was like, "Oh, it'd be great QR codes, you can watch a video. Who doesn't have a cell phone?" Except for then someone reminded me that not all parts of Maine have reception. What do you do when you're on a job site and you don't have any reception? You can't watch the video that's on
Mhm.
and so it's like, oh yeah. So
Mhm.
what things need to be in 3D because 2D is not enough. And if you put fen trim on in the wrong place too many times, that is a very expensive that's a
Yes.
very expensive. So
Mhm.
yeah, sorry, your original question was like what's different, now and what's
No, good deal. But you are answering a lot of questions
yeah.
all at once, which is nice. And then I think you're also clearly describing kind of the differences between kind of learning how you want the houses or buildings to go together, and then creating a systemized approach and looking at systems versus products.
Yeah.
And now you're in a place where you're trying to create an operational kind of a operating procedure where people know how to take what you've learned, which is great actually. That's super interesting because I think that's what makes it actionable.
I also think one of the other things that I said that was go to your job sites, even if you get value engineered out, because as the design team, that is how you learn, no matter what. It's good for your team, it's good for everyone. But I think that's also trying to get rid of the like architects and builders have an adversarial relationship. And the reality is so many builders that I work with now want to have a collaborative, really respectful relationship. And so we don't do bid work. We ask our clients to pick the builder during schematic design. I don't buy materials. So how am I supposed to build to your budget if you have a hard fixed budget, right? And so we bring the builder on. They're part of the design process. They should get paid for this time. This is not free time on their part. And we have a very respectful, collaborative thing. The client gets what they want because it's within budget. We help them to go from the wish list to the must-haves to design it in a way, right? And it's just a really great experience. And someone asked me, how do you determine the success of a project? And I said, the builder, the owner, and our team want to have, insert coffee, drinks, whatever on their terrace when we're done. That's a successful project. We all still like each other.
Yeah, a successful project being one where everyone still wants to have coffee or a drink together when it's done, that is a great KPI. So this next clip features a question from Carrie, who is a Reimagine Buildings member. She works in retrofitting affordable row homes in Baltimore. So historic masonry, shoestring budgets, also workforce training goals. And in our session with Ben Bogie, the Reimagine Construction session with Ben Bogie, Carrie brought a kind of live job site question to the discussion. She shared that when she went to the site of one of her projects, she found that the team there had done some unexpected parging with a mortar mix. And her question is, can that work as an air barrier? Ben works through it with her, also with input from Peter, another member of the collective.
So at the moment, like I said, I'm working on a couple of retrofits of row homes in Baltimore. And fortunately, I'm starting with just, it's a gut. The one that's I've got pulled up doesn't even have a roof. But we're working, as I said, with affordability, trying to do low-tech solutions and workforce training. So in talking with contractors, it was like, well, we could do lime plaster on these bricks, on the interior of the bricks as our air barrier. Or we could do, kind of clean up the brick and do the Viscon. And most contractors have said, well, labor's probably easier on the Viscon. Let's just do that. So I went out to this job site and they were supposed to just repoint the brick because it was in pretty bad shape. So just get it kind of so it's not going to fall off the wall. And they ended up basically purging the whole thing with like mortar mix. And so my question is, I know it's not lime plaster, but will this mortar mix as a material, which is mostly sand, work as the air barrier? Or do they still have to go over all of this with Viscon?
It should work as an air barrier.
Okay.
That being said, just like any barrier, it has to be continuous and detailed at turns and penetrations.
Right.
But Steve Basic has a funny one that always sticks with me. He's like, if you're wondering if it's an air barrier, put your lips on it and blow. And like last time I tried to blow through mortar mix, I wasn't getting very far.
So you have tried it.
Yeah. I mean, don't judge me.
Good to know.
But no, yeah, it is. It should function as the air barrier as long as it is continuous, and another caveat, well mixed and homogeneously applied. Because if you were to mix mortar mix dry or incompletely, you can have pockets of aggregate with not enough Portland in it, and those areas could still remain porous. So there is a little QA QC that's needed of the installation to be able to say for sure that it will function as an air barrier, but it should function as an air barrier.
Okay. Well, if that's true, then they just saved a lot of money, and we found a easy way to to do this. So, yeah, like we'll fill all the joist pockets, and the barrier will be at the floor level.
Just
like first
one
floor
thing,
level.
so I'm trying to spin this another level, which is like, what if we wanted to deploy this as a repeatable method that we could use because it's proven to be cost effective?
That's the idea, yeah.
So the next thing that I would do is to look at doing a bond or primer coat of some sort onto the masonry before doing the parge, and possibly adding a little bit of an acrylic admix into that parge coat just to make sure that it handles movement, stresses, differential cracking better than an unmodified based material. So some sort of acrylic admix.
Just think about flexibility.
And yeah, and also keeping in mind, depending on the age of this masonry, if you're dealing with existing lime mortar, you'll want to spend some additional attention making sure that you're down to sound material and that's properly prepared. Otherwise, you're going to end up with a weak point at the interface between the new and the old material.
That's my one concern here, is about differential movement over time, because it is a very rigid material and it could shear and separate from the mass masonry and then no longer be functioning, which is why I'm saying that if you can do some sort of bond coat, and that bond coat doesn't even have to be an acrylic, it could just be like a Portland slurry that you use to wet and prime the surface before applying that mortar mix on top of it. I think juicing the mortar mix is important with an acrylic admix, and you could even just add some glass fiber to it also. Like, that stuff's pretty cheap. These are base, low cost additions to that existing mix to get better performance characteristics out of it.
Okay.
And do you have an application method that, because ideally with something
like a hopper,
that,
I would think a hopper gun
yeah,
is going to be a great approach. Look at the stucco industry for their application tools. And yeah, hopper gun followed by somebody back troweling behind them just to burnish it into the surface, and what they call burning it in, right? So that you know that you've got good bond. That seems like a very fast and probably cost-effective approach.
Yes, but to ask Carrie, it looks like it was sprayed on. Is that true?
I don't know, actually. I mean, they were doing it when I was out there, and it looked like they were troweling it on, but
it looks like it's just a very rough toss trowel. They're coming off the hod onto the wall. That's a very common thing in like Eastern Europe, where they do like the AAC and the terracotta block buildings and stuff like that. They just kind of hob it onto the wall.
Well, it could also be what they do in South America.
Very similar building typologies. Right?
You could probably even test a section of that where you just take, so you basically tape it off and try to blow or suck air through it in a measurable way, and see what the existing field condition is.
For a QA QC, I do like a knock test. So go around and tap the surface and listen for hollows, because if you have any hollow sounding areas, that's indicative of an area of poor bond, right? Just like if you have a hollow sounding ceramic tile, that generally means there's not proper thin set or mortar adhesion underneath it.
Right. Okay.
As a natural building contractor, you're doing tons of lime and clay plaster systems. I'll tell you, what they're doing, they could have totally just replaced with lime plaster if they knew how to use the material. It would have been the same amount of labor, roughly.
Yeah.
Well, when I looked at the cost of lime plaster, it was just crazy expensive. So I don't know if you have a, especially compared to the mortar mix these guys are getting at Lowe's.
The material is expensive.
Uh-huh.
Did you guys
Compared to
talk yet?
mortar
I'm
mix
sorry, I had
is
to
so
take a.
commoditized, it's hard. We don't have the supply streams for like slaked lime like we used to, right? Like Portland cement mixes are Lowe's, Home Depot, the hardware store, the lumber yard.
I had to take a call for just a sec. Did you guys talk about the freeze thaw implications of this and the nature of the brick? I know Ranger Penny put something in the chat that was on my mind as well. Ranger,
It
did you
shouldn't
want
matter being on the interior.
I only ask because are you doing anything on the exterior as well, Carrie, to keep the moisture off the exterior?
No.
So there's a clear sealer you can put on the exterior that's vapor open to keep the bulk water out. And is this in a freeze thaw climate?
Yeah,
Mhm.
Baltimore gets cold enough for
Baltimore,
sure.
I've had forgotten. Thank you. So when we do historic retrofits, if there's any insulation going on the inside or the temperature differential is, great in certain climates, depending upon where that freeze thaw and dew point and heat transition is happening, if you aren't keeping the water off the outside of the brick gets saturated, it's porous,
Right.
especially if it's softer. And usually face brick is pretty and hard, side brick is soft, and back brick is somewhere in the middle, right? And what we see is it gets saturated, it gets frozen, and then the faces pop off.
Mhm.
So
Right.
Can I throw a hot take at that for you, Shannon?
Please do.
I will always advise against relying on topical water management systems. If you're having to rely on those in order to maintain the durability of the assembly, you shouldn't be doing that assembly because they rely on, first off, they don't last nearly as long as people say they do, and they need to be reapplied at regular intervals. That regular interval is generally from the manufacturer said to be 3 to 5 years. In practice, we see it more like 1 to 2 years. And if the assembly is going to start to fail, if that's not maintained, then that's not an advisable assembly in the way I see it.
Thank you. The 1 to 2 year.
Don't do the insulation at that point. Then don't do less insulation.
Yes.
Just go for
Or repoint with lime-based mortars so that it can handle that wetting and release.
Yeah.
Right. Most of the issues that we have with the freeze thaw and moisture accumulation is because they're repointed with a type N or a type M. And you have differential expansion and the soaking. And actually, according to Stebrick, it has nothing to do with freezing. It's the osmotic pressure of salt transfer that causes this.
Great.
Don't do siloxane unless it's like you put siloxane on a chimney that you got to limp along for a year or two until you can rebuild it. Don't do it on whole buildings.
Thank you, Ben. That is great advice. I've read a lot of Stebrick articles about this subject, and we're actually considering putting a presentation together on this subject because so many buildings in New York City are landmarked, and
Agreed.
some of the inspectors will let you put a siloxane on, and some of them won't. And but I think this is a great discussion. So thank you. Did this answer your question, Carrie?
Yes, it did. Thank you all very much.
So shifting gears here to an Ask Me Anything Friday with Ed May of Building Type. Ranger asks about thermal mass and phase shift, particularly in wood fiber insulation. This is something that this phase shift with natural materials and the advantages of that is getting more attention in Europe. And his question also touches on a bigger shift in how we evaluate building performance.
I've been looking at natural insulation materials a lot and wood fiber, and it seems like in Europe, one of the big drivers for wood fiber and one of the big perceived advantages is the thermal mass phase shift. So specifically for summertime comfort, so for roofs and for southern exposure exterior insulation. And it's really noticeable that in the marketing materials and most of the building science stuff that I've read coming out of North America is R value is kind of the only metric being talked about. And it seems like there's, in a lot of cases, we're specifying materials that don't function as well in the summertime, like foam, And I was curious if, from your perspective as an energy modeler, whether when you're doing WFI or PHPP, how much you're looking at the thermal mass, the thermal diffusivity, the phase shift, the decrement factor, in addition to R value.
It's a good question. I would say historically not much. And a lot of that is based on the modeling tools that we have used historically. So for the last 5-8 years or so, most of our work has been in the passive house sphere. And those modeling tools, WFI passive and PHPP, they really do not allow you to input density, specific heat capacity, any of these types of really material specific values at any level of like useful resolution. Now you say, oh, wait, no, WFI has all of this detailed input for all of those values. And that's true, but that's the other WFI. WFI passive ignores all of that information. It does not care about density. It does not care about specific heat capacity. In no way is that relevant or part of WFI passive, which is sometimes people conflate those things and they sort of get them mixed up there. But the tools that we're using to evaluate annual energy performance and certification, they only sort of in the vaguest way incorporate those values. So they're not can't disregard them, but they're relatively crude in the way that they're incorporated for annual energy and certification assessment. Now, the reason I say it in that way is because things are changing a little bit. So, historically, the last 7-8 years, it's been all annual energy modeling, but we are definitely, I think, entering into a new phase where people are asking us to look more closely at things like resiliency assessment. So like you're going to do an hourly model of a peak winter power outage week, and you're going to assess comfort and habitability during that winter period. Or conversely, you're going to look at a power outage week in a summer heat wave and see how the buildings, preserves habitability and safety for the occupants. In those scenarios, those types of material parameters become much more important. And we're not going to use those same static energy models like WFI passive and PHPP. You're going to use different modeling tools in order to try and capture the nuance of that heat and energy storage and release. And so, we're having to sort of shift to a new generation or a new set of tools that we use, not necessarily in place of PHPP and WFI passive, but alongside them. So we're still using those traditional passive house tools to do things like certification assessment and annual energy, but now we're supplementing them with these, in some cases, more detailed hourly model tools in order to do, in particular, these types of resiliency assessments or habitability assessments for certain cases. It's case by case at this point, because there's no real certifications that have built up around those. So it's still kind of idiosyncratic the way that we kind of move through them. FIAS has their Revive certification, but that's still in its really nascent form. And so, it's not really something that you would roll out at scale or on lots of projects or something. It's still kind of experimental in some ways. So yeah, it's definitely becoming more important, but you're right. Like over the last decade or so, it has not been something that we've really paid that much attention to.
So our approach to modeling needs to be evolving, moving from annual energy models toward hourly simulations that can help answer the question of how does a building hold up during a week-long power outage. And also this move to electrification opens up a whole new set of design questions. Reimagine Buildings member Mike Dudek takes it there in this next clip.
I'm up in Chicago, the north. I don't care so much about the cooling portion, but I appreciate what you're explaining. But the heating, with the grid being, it's going to be taxed. They say that we're going to double the need for power, electric power in the future. What is the safeguard heating system if the grid were to go down? I mean, you have electric cars and you have data centers, and it's a big deal these days. I just had my brother want to replace his furnace in a energy efficient house, and he had to make a decision. And I said, with the grid and stuff, I said, go get the 97% furnace and replace it, because you need a new line set. You need a lot. I mean, you put a battery backup to support if you do a heat pump, you got to put, so it's
sure
getting to that area where electric's going to probably even get more expensive as well.
Yeah, that's a good point. Yeah. So, yeah, it's certainly here in New York, you're talking about a lot more than a doubling of the capacity. I think in New York State, where I'm practicing, they're talking about like, I think they want to get to 120 gigawatts, 100 to 120 gigawatts of installed electric generation capacity. Right now we're at what, like 20 to 40 or something like
Yeah.
that. So we're talking about it, maybe a 3x increase in electric generation capacity. And you're absolutely right. The sort of peak grid consumption is projected to move from a summertime peak to a wintertime peak. So right now, because most of the electricity, at least at the residential level, is used for air conditioning, that peak occurs in the summertime. But that's going to change, and you're right, it's going to move to a wintertime peak, which is absolutely going to have all sorts of effects on the way that we have to build out our grid. There's no perfect solution to that other than, yeah, just as you're
Put a battery
describing,
backup.
right? The way that we store energy right now is in batteries. And so doing, different layers of battery backup is going to be really important. But it's definitely the case that it's something we have to contend with and think about when it comes to building these resilient buildings. I guess I would say, I think the reality is electricity permeates everything. So even that 90% efficient boiler probably has an electric fan or a control or a ignition or something on it, right? So without electricity, even that thing's probably not working. Now you could run that off a very small battery backup, right? It's not like running a heat pump. So you're absolutely right. Like there is a resiliency in those types of equipment that you don't find in a direct electric or a heat pump equipment or something like that. Um, I think we will I believe that we'll be able to manage that challenge at the grid level. I think at the individual level, it is harder, right? It's kind of that thing that people wrestle with, whether they're like, oh, am I going to do the full electric car or do I go with the hybrid? At the individual level, it's still kind of a question of your sensitivity, your sort of openness to risk, your risk profile. Like, how bad is it if you lose power for a day? We lost power for a day or two growing up. We lost the heat. We had a fireplace, run the fireplace. Everybody sleeps in the living room. It's not the end of the world, but I'm not an old person living by myself where the risk profile is a little different, right? So you kind of have to be sensitive and thoughtful about who it is that you're building and designing these buildings for. What is the level of risk tolerance for the occupants of those buildings? And it's going to be different for different populations, right? And so, yeah, I don't have a great answer other than to say, like, yeah, batteries and electrification are definitely like the wave of the future, but they are not silver bullets, right? They are not like without problems. And so those are definitely things that we're going to have to struggle with. One really simple thing that we could have done or could have been doing for decades is to bury the goddamn power lines. We cheaped out on running power lines for decades and decades and decades and ran them up in the air. We could have been burying those things for the last, 4 or 5 decades, and then we wouldn't have as many power outages, but we didn't. And so, right, we kind of have to deal with the grid that we were dealt, not the one we wish we had, right? And so, yeah, batteries and electrification, I guess that's the direction, though.
Well, this episode covered a lot of ground, starting with Emily's story about starting her architectural practice during a recession, pivoting to Jesse and how to pitch investors on spec passive house development, then to figuring out if mortar mix can be an air barrier in a masonry row home. So we a big range, but what ties it all together is that we have people figuring it out, and not from a textbook, but from the work, and doing it alongside others who are figuring it out too. And that's what the Reimagine Buildings Collective is about. It's conversations that go where the work goes. The messy, practical, unglamorous details of better building and how to make a living doing it. So if any of this made you think, I wish I could have asked a follow-up, that's what membership is about. The Reimagine Buildings Collective is where you go when you're navigating something hard in this work and you need people who've already been through it. So please join if you haven't already. Visit reimaginebuildings.com to do so. And speaking of joining, I want to welcome our newest members, Zahra Ali Shapiro, Chris Pressey, Nelson Yuan, David Peabody, Peter Levine, Kim Cloutier, Natalie Tagg, Matt Hutchins, Ronnie Murray, John Lipman, Donald Proven, Kara Biondi, Ryan McGowan, Scott Moulton, Hillary Paget, Anthony Harrington, Donald Glockner, Dean Freeman, Wendy Pascal, Miranda DeLeo, Emery Baldwin, Kritika Karbanda, Jeff Geisinger, Toshi Wodenberg, Amy Faea, Michael Schmidt, Shilpa Sarana, Becky Bicknell, Linda Corson, Catherine Murphy, Crystal Eng, Heather McKinstry, Christina Held, James Peterson, and Kevin Loftus. A big welcome to Reimagine Buildings. And thank you all for listening to episode 16 of the Reimagine Edit, a production of Passive House Accelerator. Please stay tuned for our next episode, and in the meantime, be well.